they are very heavy. The Myco 2 also, it is just a scaled down version of the Jacko. This is a 70 centimeter long robot, the 6 degree of freedom. And the features of be it of the Jacko or the Myco, they are almost the same. I somehow can't see the charts over here, but they weigh between 3 to 6 kg. The payload is also between 3 to 6 kg. I'm going to keep brochures of the products over here, so you can get a idea of, these are the two major parameters that they look for, weight and payload. So that is there. Weight is 3 to 5 kg, payload also. In gripper also you have got two kinds of gripper, 2-finger gripper and a 3-finger gripper. I'll show it in the videos. So you basically, while choosing a robot arm, you can choose whether, according to your application, whether you want a 6-DOF arm or a 4-DOF arm, depending on the weight, payload and reach. These are the three features. Reach is the maximum distance from the base to the end point, how far you can go. Then you can choose the gripper. It can be a 2-finger gripper or a 3-finger gripper. And then you can create your own robotic arm. So there is another chart over here. So each of them, this converts into 12 types of robotic arms essentially. For the 6-DOF or 4-DOF arm, in Jacko, you can choose these two variations, and you can choose without a gripper, in which case you have to build your gripper, or we can supply you with a 2 or 3-finger gripper. Now suppose, some more features. It is 5.2 kg. The weight, the payload varies between 2 to 5 kg. This is the previous version. It works on very low voltage, 18 to 29 volt DC, and this makes it a very high favorite for inserting it on top of mobile robots. Because on mobile robots you have two constraints. One is its payload. The second is the power. You are drawing battery. So you can, if you consider keeping a 50 kg robot on top of a mobile robot, your battery will drain in no time. As well as if you are carrying a huge weight, it might become unstable also. So it's very lightweight, very low power consumption. Base control programming is through USB. You do not need to put this in a cage, where typically in an industrial robot, the controller is of 100 kg. In your robotics lab, you must have seen there is a separate robot, and it's not that open source also, neither in terms of software nor in terms of hardware. So the programming language is C++. The drivers are written in ROS, the robot operating system, which I'll come to in the next slide. It can be programmed through USB. Now suppose you are not satisfied with any of the robots that we give, and you want to build robots from scratch. We also provide the actuators. These are the same actuators that are given as part of the 6-DOF and 4-DOF arms. So there are 3 types of actuators. There are load, speed. I won't go through each of them since due to time constraint, but the data sheets are there. So the most important part of our robotic arms is we have given a torque sensor, position sensor, current, temperature and acceleration sensor in each and every actuator. So if this is a 6 degree of freedom arm, this is a torque compliant arm. I'll show you a video what I mean by torque compliant. Generally, if it is any robotic arm and if it is in one position, if you give some external force to it, it's not going to move. It remains as it is, if it is not a torque compliant arm. Whereas for these kind of robotic arms, if you push it from outside, it will bend in a certain way such that it does not get damaged. This is very important in if you are deploying robotic arms in areas which you cannot predict. So in personal robotics, assistive robotics, even when you are keeping it on top of mobile robots, you are not sure about the external environment. Somebody might bang it. Sometimes the robot arm itself might bang against something. So torque control is very important. So all the products that we give, they work on a library called ROS. I rather call it a library. It's called the Robot Operating System, and it's a huge library of code that is written in C or C++. It is being used by researchers and built by researchers. So it's a very research-friendly operating system. This can also work on Visual Studio or MATLAB. Cartesian and angular trajectory control is there. You connect it through a USB C++ language. So this is what the research edition platforms comes in. You have got a robotic arm over there, a joystick, so that you can show it to the students while teaching very easily. There is a power supply unit to convert the 230 volts into 24 volt DC. The USB cable to connect your laptop and program its trajectory, angular control, Cartesian control. It starts from basic chapters and then it goes to higher end chapters, including PID control. So all the code is open source. We have not hid any part for ourselves. API, and it's a very easy mounting kit. You can take it from the lab to your classroom, and from the classroom you can put it on top of a mobile robot in case you already have a mobile robot in your classroom. So it's an integrated package of hardware and software to do two things. One is to teach robotics, and the other is to quickly develop applications. So suppose you approach DRDO and you say that we will design certain algorithms for you. You can do that in C or C++ for them, and you will have the basic tools that are required for getting started with it. So very simple, very safe to use. It will not hurt others. It's right now being used on top of power wheelchairs. So the safety is very much guaranteed. So these are some of the applications. These are mobile robots of other companies. You will see, since its weight is so low, 5 kg, and since the power consumption is so low, it is an obvious choice for putting it on top of mobile robots. So be it a small robot or heavy outside robots, you can use it. Even in medical operations, it is right now being used. I'll show you the application video. In India, it is being used in brain-computer interface at Jadavpur University, Calcutta. One person recently completed his PhD based in brain-computer interface. He is using an EEG headset on his head, and through that he is controlling this robotic arm. I'll show you the video later on. And they have gone for another robotic arm recently. So in India, we also added a couple of more. I have not updated this list. IIST Shibpur. Two of them in Canada, in Tamil Nadu. Yeah, the other company that we represent in India and are partner for is ClearPath Robotics. So they make unmanned ground vehicles and unmanned water surface vehicles. So this is the basic architecture. There are lots of robots. I have given you a form. So I'll just tell you basic difference. The basic difference between all of them is the payload. Other than that, the architecture that we follow is simple. It's going to be a rugged outdoor mobile robot where you can test algorithms, where you can perhaps put it in mines, or as Amrita University is planning to do, use it in disaster response management. So there is basically, the architecture is like you have got a mobile robot, you have got an onboard CPU with ROS drivers installed in it. So the basic part of getting a robot and making it work with some of the other sensor is taken care of. Since and we are not necessarily that we are building the drivers. Sometimes the drivers are, since they are all open source, are built on the website, and sometimes we integrate them if we have got some special. And there are lots of accessories: camera, GPS, IMUs, inertial measurement units, lidars. I'll come to that later. So these kind of platforms we provide, completely integrated. So the advantage of using these open source libraries is somebody has somewhere tested it or tried it elsewhere. You can use that, you can build on it, and you can also put your work back on the ROS platform. It's like any other open source website which you can take advantage of. So there is a large open source library for research, navigation, vision, large number of manipulators, drivers for communication in case you want to increase the range of this robot from 100 meters to 1 kilometer, 2 kilometer. You have got repeaters, 3D visualizers, path planning tools, physics engines, even simulators are there. ROS Sim or some, that was one of the names. So this is the Husky robot that we provided to Amrita and IIIT Hyderabad. Amrita University and IIIT Hyderabad. So these are some pictures, and just quickly, this is just to show how highly configurable they are. There are different set of sensors each time. So some more features. If you, after taking the robot, you want to add your own sensors, we have made it very easy. We have taken out the power sources and we modify the top plate so that you can integrate additional sensors from outside. We give additional Ethernet ports also to the robot. So industry rail mounting, class leading 5-inch ground clearance. There is also an emergency stop. Yesterday we were Mr. Alok Mukherjee was speaking about the importance of having an emergency stop. One of the robots just kept on running and went into the water. So we also provide wireless emergency stop buttons. It's excellent in terrain handling. You can see it in near the beach and many other parts. So these are the more features, which again you can see more in the brochures I will give. But mainly they vary in payload. Rest all integrability with ROS and everything is the same. So this has a payload of 75 kg. Works on ROS. By just the hand I am going to show it. It is this big. The Husky robot. This is the Kingfisher. This is an unmanned water surface vehicle robot. So suppose you want to measure the water pollution over a large scale, over a large area in a lake or maybe rivers. This robot can be used. So this is also we can integrate it with sonar, GPS, LIDAR, camera, environmental sensors, and integrate it and give it to you. The Grizzly is a big vehicle. It has about 600 kg payload. This one. The Jackal is the smallest one, low cost kind of robot that we have built, outdoor mobile robot. It has a payload of 20 kg. So this is completely right out of the box. We have also integrated already some sensors in it, mainly a GPS, an IMU, and an accelerometer. So some basic sensors are integrated. We can also integrate some low-cost cameras if you want to. So this is pretty good for research. It is being built as a lab teaching tool. So there will be lots of tutorials that will come with Jackal mobile robot. So sample applications are multi-robot systems. Since you are working on ROS, your whole lab becomes scalable. So suppose you buy one robot and you buy another robot which also works on ROS. As long as it works on an open source operating system, you can make one robot talk to another. And then, so there could be two UGVs walking on land. If you later buy a UAV, I would suggest you buy a UAV which says that it will also work on ROS. So or a unmanned surface vehicle, so that each robot can get the data of the other robot and take local actions and do their tasks. So this is used in multi-robot systems, perception and navigation algorithms if you want to build, maybe for DRDO, maybe for the industry, environmental monitoring. So we also have indoor research platforms. They are used mainly in logistics. This has a payload of about 100 kg. We also have come up with new robots which are used in logistics and which have a payload of 2 tons. So I believe logistics, where they used it in huge warehouses, Amazon, Flipkart, pick up an object and go and place it at another place. That will be very useful. It makes economic sense, at least in the Western countries and US, where the salaries are pretty high. Over there, you need to give $50,000-$60,000 to whoever is working over there. In India, probably not. Some other applications, like maybe in coal mines for improving the safety or disaster response management, or with a DRDO, you can build some applications. Or you can also build for this also, for algorithm testing using this. But as of now, since we get employees whose salary is $100-$200 per month approximately. So keeping a robot for using the same does not probably make that sense. So this is a quick comparison. Everything works on ROS. We support academia a lot. So it varies in payload, 20 kg, 75 kg or 600 kg. How much weight you can carry. The Turtle Robot 2 is the lowest cost entry-level robot platform. This comes with a basic Kinect sensor or an Asus sensor. The max speed is about 0.65 meter per second, and you can do local things like maybe getting a glass of water from one place to another. But this is good for opening up yourself towards the world of ROS and robotics, basic mobile robot. It is also used for navigation algorithms at many of the universities, even in India. Mobile manipulation. So the two things combined. One is the robotic arms part, which is the manipulators, will sit on top of the mobile robots, and we also integrate sensors and all that. So you have got a mobile robot on which we can put various kinds of cameras, GPS, inertial measurement units. LiDAR is very, very important these days. So the difference between a camera and a LiDAR, in short, is when you give a camera data to a computer, you will see the thing in 2D. But what we do, we are seeing it in 3D. So when I look at all of you, I'm not looking just at a picture, but I know how far you are from me, each one of you. So I have got a 3D map in my head about where each one is. So when you put on top of your mobile robot a 2D LiDAR or a 3D LiDAR, you get a 3D map of the environmental surroundings. So suppose you want to, this could be used in coal mines. If you want to send it, the visibility and to using cameras might be very low. There might be no lights at many places. So it creates a 3D map, and this also helps the robot during path planning. It knows just like us where each thing is. So LiDAR is very, very important. We gave 2D LiDARs, now we are also giving 3D LiDARs. Some low cost options have also come. The lowest cost you might already be knowing is the Kinect sensor. That is also a kind of LiDAR. It won't give a 2D map, but it knows depth sensing. So how far each thing is away is, it approximately can give. That we have put on the Turtle robot. So you've got a choice at every stage. So when you're building a robotics lab in your college, so that researchers can use it over a long period, it is very important to have flexibility. Otherwise, what will happen is if the mobile robot talks a language which does not talk to your robotic arm, then these are two separate solutions. You buy one robotic arm, you teach the things related to robotic arms, and then if you want to use the same part on a mobile robot, you cannot necessarily use it if it is a very heavy robot. Of course, industrial robots are also useful, but if you're thinking of doing research related to algorithm development or mobile manipulation or all the other applications, which are also industrial applications, but more to do with mobile manipulation, then you have got flexibility. You can choose any of the Husky, Jackal or Grizzly mobile robot that will talk to any of the robot arms and also the sensors. So you can remove the robot arm or any of the sensors from that platform, take it into the lab, so where someone from mechanical engineering department is teaching robotics, take it back to the researcher who is using it. And even the sensors, camera, GPS, LiDAR, these are used by departments from electronics, electrical, computer, any of them. So remove it, place it back, that is an advantage. It's not a repetitive thing. So in summary, we basically provide anything and almost everything that is related to robotic arms and mobile robots. So mobile robots, sensors, cameras. What I will do is I will show you some more videos. I was given a task of 30 minutes, doing it much faster, I guess. So this is one that was given at. So this is the robot arm, and I'm using a joystick. It is very easy out of the box use. So on the joystick, just like a game, you can move it forward, backward, right, left, up, down. It will work accordingly. And all these parameters can be seen on the computer also. Each of the torque sensor, force feedback control, the current drawn by each of the motors, all that you will be able to see. So I had this robotic arm a month ago. I'll be having it later next month again. So if you want to see a demonstration, I can bring it probably in the next month again. This takes hardly any time. This is a 3-finger gripper. So this is what position control is. Yeah, yesterday one of the professors was also talking about position control. So this center position will remain at the same point, and he talked about 3 degrees of freedom which are used for the wrist. So you can see only these 3, first, second, third are as where they are, whereas these 3 next parts are being used for moving it in position control. This position remains the same, and it will move forward, backward, right, left, like that. So this is one video. This is another video. They are using the same arm to pick up a bottle, place it over here. This took place on the first day itself during the installation. So there is a little bit of this thing. So this took hardly 5 minutes. Trajectory control is very easy. We also provide a GUI for that. Plus we provide C++ code for you to make it move from one point to another. So this is another video. This is for mobile robots. Various mobile robots. Most of the videos that I am showing are being used by universities, one or the other university. So this is not like some of the other universities, somebody is working with coal mines, somebody is working with demining, that is finding where the mine that can blast is there. That's being used. A dual arm robot on top of this. So this is another robot. The Husky. This is used in by University of Coimbra in mine sweeping. So at places where humans cannot probably use it. So this is all on YouTube. There are many other videos also that you can see. This is the mining, demining part. This is an underground mines in Chile. This was also by one of the university, and it is showing the data from the camera. It can also give LiDAR data. So this is where you can send your robots. Sorry, I'm quickly showing the videos since I have lots of them. So this is the ClearPath Robotics website that you can take a look at. So if you go on robots, we have got robots for land, air, and sea. In land, you have got all these robots, and if you choose on any one, say for example the Husky, okay, so you can see the specifications and all over there, and it also comes in different packages. So depending on your research work, it could be a basic starter package in which you know what kind of sensors you want to integrate and you integrate them yourself. Or it could be an explorer package where we put up say maybe a GPS on top of it or a camera. Then there is an explorer package. There are 4 or 5 packages in each of them. In a manipulator package, we will put a robot arm on top of this. And it's not necessary that you have to immediately go for the manipulator package. You can go with the basic mobile robot, and in year 2, year 3, as the funding comes, because getting all these sensors at the same time, maybe if the fund is not available. So you can start with the basic part and then keep on integrating more sensors as time goes by. So this is there. In mobile robots, you can get all the details over here. Air also there, unmanned aerial vehicles, though it's very difficult to give them in India because of the permissions involved. Otherwise, we can give it up to the airport, but customs clearance becomes a problem. Yesterday somebody was talking about customs clearance also, I guess. So land and sea, there is not much problem, but UAV, these are capable of, these are almost drones which can so you got the Heron, which is an unmanned surface vehicle. In accessories, lots of sensors we integrate. So sensors, manipulators, I'll just run through each of them so that later on if you want to take a look. No, just 5 minutes. So yeah, this is the variety that we have in lidars. They vary in cost and they vary in the distance that they can do. So till now we usually had 2D lidars from SICK, LMS 1115151. They vary in how, whether they can cover at 20 meters, 50 meters, 80 meters, also in the accuracy. So these are 2D lidars. We have also come up with Velodyne's 3D lidars. This is a low cost, comparatively low cost. Everything when I mean low cost, it's a little bit comparative. But in terms of 3D lidar, it is a very low cost lidar. There are some more lidars from M2U00047 also. So these are all different companies, by the way. What we do is we make the mobile robot and we develop the driver and give it to research universities. So that the basic part of getting started, if they want to do research on algorithm and all that, they do not need to reinvent the wheel again and again. Like all these things are already available. So maybe they could get these parts and get started working with the application itself. So there are many others. There are different kinds of cameras. Pan-tilt zoom camera is there. You have got night vision cameras, color cameras. So all these vary in costs and the quality. The GPS also varies from an accuracy of 1 to 2 meters to 2 centimeters. So depending on your application, you can go for the GPS. We also provide sonars. So lots of manipulators. So we are partner for this Innova robots. But if you want, we can also integrate other robots, maybe from Universal Robots or Rethink Robotics, any of them, and integrate it on top of the mobile robot platform and give it to you. So this list keeps on adding up. If you want better processing capability, we have got 5 to 6 computers that we give. Okay, controllers, there is a variety. What kind of joystick you want, whether you want an HMI, whether you want an emergency wireless stop button, whether you want a Panasonic Tough Book. So there are basically some applications in which you want to build it from scratch. You want to do some innovation in building it from scratch. It could be you are inventing some part of the robot which is not available in the market, and there could be other things in which you have been given a specific task for creating an application, or you just want to set up a basic robotics lab so that different applications can be done by the students year on year. So for that our products are basically useful. So this is Innova Robotics. Again, as I said, it's Jacko and Myco, 2 types we give, 6 degree of freedom or 4 degree of freedom. And so you got robots, even the actuators, that if you want to build your own robots, that also we provide. These are some more videos. So this is say a universal robot on top of, this is, as I said, very much used in navigation in logistics. So you want to pick up an object and place it at another place. It makes a huge monetary sense also to do all this basic activity. So what I would request is, if you have any specific research in mind, you can put it over there. There is just last point what I wanted to say is, this is the slide that I just added. So I would suggest try making applications which at the end of your research are useful for industry. This is the only way because of which industry will come and give money over here and for building applications. Otherwise, usually what the funding as of I know is either from TechWave or one of the own funded. That is the way it goes. So in India, as of now, universities going to colleges and saying that you complete this project for us in this amount of time. We will fund you this much. That environment as of now does not exist, which can be done in robotics. ClearPath Robotics and Innova Robotics are both examples which started in the university by some of the professors. So That is an option. We from this year are going to start sponsoring some robotics projects which are useful to the local industry that I come from. Textile industry is there in our area, and also home automation. So these are two areas where we are sponsoring some projects. And I would wish you all the best. Your research really makes a difference in someone's life. So thanks a lot. I'll keep the brochures, by the way, on the table for the next 2-3 days. Whichever products you like, you can take a look, or else send me a mail and I will mail you the brochures. Okay. Thank you. Any questions, by the way? You can ask now or in the tea session also. It's exactly 11:45, by the way. Any questions you want to?
So the Spinova robots, all the control algorithms we can change.
Yeah, you can change the algorithm. So what you can do is you can also go on the website, and the code is already available. So the software. So the ROS code is already available. So you can give it a try in Visual Studio.
Is the low level control also changeable such that the PID control, or can we tune the PID parameters?
You can tune the PID parameters, yes. There are specific codes for this that is available. So I can if you go on KinoaRobotics.com, just go on the software part and download it. In C++ only you will see the library, and it will also describe for PID control function which is the function and what it does. For Cartesian control, which is the C++ function, what parameters you have to send and how will the robot move. Same for angular control. So that is available.
So what is the safety?
Yeah, so
safety is assured because if one changes some parameters,
yeah, so what happens is the Kinova is specifically designed for research purposes, and it is designed so that you can be very close to it. So in the initial robot, the Jaco, which started in 2010, we did not have something called as the torque control or the force feedback control. So suppose this robotic arm, if I give it a command to go down, there was possibility that this robot arm might get damaged. So now what they have done is they have put a force feedback control and current sensor in each of them. So now if you try to push it down, it will move like a human hand. It cannot move down. So the other actuator will move. This will slide and go down.
What I am talking about is, if at goal I was say, if one increases the gain of an actuator, so there should be some saturation on how that safety is handled.
Yeah, so so there are two parts. One is when you are using the joystick, we define the speed, maximum speed. But when you are using the code, over there also the maximum speed they have given for the robot is something like 20 centimeter per second. So even at maximum speed, if it is hitting, it is not going to hurt anyway. It is made of it is a 5 kg robot arm. So including the controller, it weighs between 4 to 5 kg. It's made of carbon fiber or reinforced plastic. So by 20 centimeter per second, you can consider at most this much at this speed. So if something hurts at that force, it is not going to hurt somebody. Yeah, I mean, of course, if somebody has a seizure or something in the gripper, I don't know. Yeah, as far as the force is concerned, it's not going to hurt somebody. Please give the feedback forms if possible. Yeah.
Can you be specific about the material being used for the lightweight robot?
One is the carbon fiber structure and the other is reinforced plastic. By the way, I forgot to mention one part. We are giving the actuators with which you can build your own robot arms. At the same time, we can also give the carbon fiber structure. So you give us the 3D design. There are two parts. So one, if you want the printer, we'll do the same thing. We'll ask a 3D printer company. They give online services. We'll send your CAD design to them, get it manufactured and send it to you. The same thing happens in carbon fiber structure also. It's stronger than most of the metals, far stronger than I believe steel or many of them. And At the same time, it is super lightweight. So we can give that. You give us the 3D design, we will give you the part. If you want something longer, some link will have to be longer, some link to be shorter. Yeah. Okay.
ഇവിടെ അതൊന്നും വേണ്ട.